Hello there. Welcome to Engineering Drawing Made Easy. In today's video, we're going to work on a 10th tangency problem. And then this tangency problem is it's part of a common tool that we've all seen. So yeah, to some of you, most of the things that have been drawn will be kind of abstract and you might not even know the relevance of what we are doing. But then this is part of a tool that we've all seen before. So um yeah, we are going to go straight forward into it, and if you have any questions, you leave it in the comment section, or any thoughts, you can also leave in the comment section. With this particular figure, we start from a key central point where most everything revolves around, and that will be the center line. So we start by drawing that. Okay. The next thing to do is to draw the center line. Yes. So you locate the 30 degrees offset from the center line. And then at a point of origin, you draw another center line, which is at an offset of 30 degrees. Yeah. I mean, I've made a whole lot of repetition of the same exact thing, but I believe you get what I'm trying to say. Now, with this, we're getting the 30 degrees angle. There are two ways to go about it, right? You can either use the set square. This is the 30 degree set square. This is the 60 degree set square. You can use that, or you can use the protractor to read your 30 degrees of that line. So yes, so let's have this as a center point, right? Now, if you are to use the 60 degrees set square for this one, I think that would be a lot easier, but you'd have to know how to handle the instruments properly, right? You just set it this way. You have this side flat on the set square, on the T square, and then from here, whichever line you draw will be 30 degrees away from this center line, right? So you'd have to understand the instrument and how it works very well. If you turn it this way rather, and then you draw the line, the angle from here to here is going to be 60, right? But if you turn it this way, the angle from here to here will give you 30. So that is one way to go about it. You have to understand how to use the tool very well. But you can use this, you draw the line, and then you have your 60 degrees. Yeah, you have your 30 degrees, sorry, like, from this line. But I'm going to use the protractor as well, so that it could be feasible for everyone. Depending on which way you choose, you can work on that. Now, if you want to be good at engineering drawing or yeah, technical drawing, you'd have to master the tools for drawing and how to use them very well, right? You realize that I extended these lines. Ideally, they are not really paths, but I need them if I want to read the protractor correctly. So you have to take your time, learn how to use the tools, and yeah, it will make working easier for you. Okay, so now we have our protractor set in place. We are trying to get 30 degrees away from this angle. From here to here is 90. You come up to 60 here. On this mark, from this point to this line, use as 30 degrees. Okay, so we are making some progress. You might not see it yet, but I'm making progress. Um, the next thing we can do is draw these two parallel lines, right? Now, if you take a look carefully, they are obviously parallel lines, and they are separated at the distance of 38, right? 38 mm. So if this line just falls between it, you just divide the 38 by 2, and then that will be the distance from the midpoint to the other line on both sides. Now, there are several ways to construct parallel lines, right? But for the sake of this example, I'll show you one way to use the set squares to construct a parallel line, because this time around we need it at a particular interval in relation to a particular plane, right? Or reference line, which is the center line. So, um, yeah, if you want to use the pencil and compass approach, you could do it. It would take a lot of time. Let me let me show you another simple trick you can do it with just the set squares, right? So, first of all, 30 divided by 2 is 19, right? So it means this line is 19 from here, 19 from here. Just do some magic with this. You make sure that rule, the 19, the 19 mm line or point is exactly on the reference line we want to draw. Now, after doing that, you just mark the 0 point on the rule here. Then you come over to mark the 38 points here. Okay, so from this, you've been able to get the equal distance or points separated from this line, right? You've been able to get 19 from here and 19 from here. That's what we're interested in. So now, the next thing you're going to do is you're going to pick both of your squares, right? Your set squares. And then you're going to set the 40, the 45 degrees on the line, the plane that we are interested in, the 30 degrees plane. I'm going to set it on it. Make sure it's exactly on the line. And then you set the 3060 or the other set square against it. So you must make sure that it's exactly on the line. Doesn't this two meet uh, firmly, and then the set square is still on the line. Okay. So now that you have that, you keep the base one firm, right? The one at the base, you keep it very firm, you hold it down very firm, and then you slide the one on top of it, right? So when you slide, it should be able to come and meet the line again and fall exactly on it. You should fall on it such that you can trace over the line again against the edge of the um set square. Okay, so this is really important. It's important you pay attention and make sure that everything is in line, or else the line you end up drawing will not even be parallel or not inclined to the plane you're interested in. And so you slide until you meet the point you're interested in. Okay, all the while holding the base firmly and then making sure that the top one to sits on the plane, or no, on the set square. Yes, you get to the point you're interested in, and then you draw a line through the point, right? Okay, and you slide it over. Move on to the next point while still holding the base firmly. So there you have it. You have your parallel lines. Um, yeah, you can deepen it out of extend it however you want. But then that would be the parallel lines that you need, right? Yes. So like I said, we are making progress, but it might not look like it. Up to this point, most of the things we've been doing is or are constructional lines, right? But then let's go into something more visible or prominent that you'd notice is progress. These two circles here. If you take a look carefully at the figure or the problem, it shows that they are their radius, right, originates from this center, and this center is where everything else has been revolving around so far, from the 30 degrees angle to the parallel lines. Everything is kind of revolving around this particular point on the line. So that would be the radius for this particular arc of 54 millimeters, and then also this arc of 25 millimeters. Okay, the next one, 54. Now, so if you have been following the tutorial so far, or if you have been learning so far, you'd understand that since these two originate from the same um, center of origin, they will be concentric circles, right? I mean, that is the term means they are parallel, they will never meet and all that. But if you look carefully, there are other radii here, right? Radius of 31, the radius of 31 here. So that means that the curvature is different, and we must find their center of origin as well. So yeah, once again we've made progress. Let's move on to the next thing. Another key thing will be this dimension here. from the center point to this point of the parallel lines is 13 millimeters, right? So we'd have to measure 30 millimeters and then cut the parallel lines off at that distance because that'll be the end for the parallel lines. So to go about that, we take our divider, we measure 13, then we mark 13 points on the line. So with our set squares again, this time you're going to draw a perpendicular line, right? So we set the long one at this line here at the base because then it's supposed to be parallel, right? So we set it at the base, then we come up with the 45 set square. This gives us a perpendicular line. Okay. Yeah. So this will give us the points here, right? Distance of 13. That's where the line ends. This will give us those points. Now, like I said earlier, we've made a lot of progress, but this particular problem, you wouldn't see much progress until the progress starts showing. So, yeah, you'd have to take your time trying to understand everything. There are a whole lot of constructional lines and then backgrounds you have to build on before the work evolves or shows up, right? So, take your time, follow through, and clean some of this. Let me clean some of the constructional lines that wouldn't be needed again. Now, the next thing would be to draw this arc, right? Because then we've found this point, you've drawn this one. So we use the rules of tangency to locate the center for this arc, and then we we draw it. Since they touch internally, it's going to be this radius minus this radius, which is 54 minus 31. That gives us 23 mm. Then we go on the distance from here to the center, which is 31. So now this point has been located as the center. We draw the arc from there. We clean this part. Yeah, so we've done for the upper parts. Let's repeat the same procedure for this other side. Okay, so let me clean this part as well. Then let me clean some of the other excess constructional line that is not bringing out the work properly. Yeah, so now as you can see, we have indeed made progress, right? We are done with the entire head of the figure, just level with this bit here, and then that should be the easiest component of the entire work, right? Because there's a ten, there's a tenth, yeah, there's a tenth tangency problem, and um, we've handled similar situations several times. So I could confidently say that we're about 70% done. Yeah. Yeah, moving on. So once again, if this video has been helpful so far or you found it interesting so far, kindly subscribe to the channel if you've not already done that. And also, if you've already subscribed, share this with your other colleagues or other students who you think might need this video as well. And also let me know your thoughts in the comment section. It's really important. If there's a part you couldn't understand, the parts that you want to make some contribution, anything, just leave it there and would reply you on that. Now, the next thing we'll do, we'll have to draw this parallel line here, and then we go on to draw the axe attached to it, right? It says that the distance from here to here is 34, right? That means from the midpoint here to here should be 17, and then from here to here should also be 17. So let's use our rule and then repeat the same trick we did for the other set of parallel lines. We put on our rule and make sure that the 17 is on exactly the line, reference line you're interested in. Then you mark the 0 point and then the 34 points. Now with these lines, you can easily construct it using the t square and then the set square, right? Because it's just a vertical line. So let's do that real quick. Yeah, so with the t square and the set square, you can easily do that, but you have to make sure that your tools are right, your drawing board is correct, and then um, everything is in line. Test to see that it's parallel before you use that. If not, you'd have to construct the parallel line using the construction method. Now, the next thing would be the arcs here, right? So this particular arc touches this one at exactly 1 point, so it's going to be the sum of the two radii. That gives us 56, right? 25 plus 36 gives us 56. So with our compass, we try and locate the center. Now, the next arc is going to be 25, right? Now, with the radius of 25, I'm going to show you one trick that you can use if you're in doubt or you don't have much time, right? Ideally, what you're supposed to do is that you see this part of the work is an arc, right? So you'd have to draw another um, horizontal line here that is perpendicular, and then from there get exactly the distance from that point to the 25 points, and then use that to try and find the distance or the center, like the usual process that we've been doing, trying to locate the point where the circle touches the line at exactly 1 point, and then use that to find the what do you call it, the center of the arc. um that is the right way to go. That is the genuine thing to do. But if you are not sure where the center is, or you don't have much time, right, one thing you can do is that the center that would make it tangent to both arcs is on this line somewhere, this arc that we've drawn, right? So wherever the center is should definitely be on this line, and then you know that the distance is 25, right? I mean, if this confuses you, you can just um ignore it and do the procedure, right? But if you want to learn this trick as well, it can be helpful in sometimes. So yeah, the center to draw this particular arc here lies on this line somewhere. So this is the time that you have to do try and error, right? You open up the 25 mm, and then you kind of trace it along the line, see where it will touch the circle at exactly one line. This kind of extends a bit, but it will definitely touch the circle at 1 point. So you go, you keep going a bit until you find a point where it touches the line at exactly 1 point. Right. So I found it. It's between, it's at this point, this particular point. We'll touch the line at exactly 1 point, and then we'll touch the circle at exactly 1 point as well. So let me draw it out and you see. There you have it. Touching the line at exactly, touching the line and then the arc at exactly 1 point. All we had was this arc, and then we kind of trace it along the line to find where it meets. This is a lot easier and faster if you understand what you are doing, and then you don't have much time to be drawing all those lines that is required of you. Let's say drawing a test or something, or sometimes you're not even sure how to locate, work around locating the second arc. You can use this approach. So we'll do the same thing for the other side, just so you see it being used one more time. um let's locate the distance where the arc, the center would be. by adding 59 and then 54, because then it touches the 54 arc here. 59 plus 54 is 113, right? 113. So okay, so now with this 113, we found a possible we can find a possible point where the 59 arc will touch this line and this arc at exactly 1 point, right? So we open up our compass to 59. Yes, and then we try and gauge where we would meet the line and also meet the circle at exactly 1 point. Yep, I think I found the point. Yeah, so that is it. That is how you go about this particular tangency problem. And that was also as I was trying to show you. Um, yeah, if you are ever in doubt on how to locate the center, you just find one of the arc, play around it, and then you would definitely get the arc drawn. Yeah. So that'll be all for today's video. Um, if you have any questions or any feedback you'd like to give, I'll be really glad to hear what you think. Leave it in the comment section, and uh yeah, as I've always been saying, if this video has been helpful and you've learned something that you think is useful, then it would be nice to subscribe to the channel, share it to other colleagues so that they can also get to learn um the same thing. That'll be all. See you next time. Bye.